So this is lesson 6, the last concept that we need to review based on the lessons we did prior to the March break. So for lesson 6, we looked at the significance of the factored form. So we started with this minds-on activity, so graphing from factored form. If you're in my class, you've already done this worksheet, but I'm going to go through it again so that you remember essentially what we discussed. So here are 4 quadratic functions. The equations are in standard form. Write the equation in factored form in the blank provided. The graph of each parabola has been provided for you. Rewrite each equation in factored form. So we have 4 quadratic functions on this page. The first thing we're going to do is rewrite it in factored form. So this should be review. We did do factoring in our previous unit, but I do want to show you this again, just for one example so that you remember how to factor. So f of x, I'm not going to factor out or change the left side, so I'm going to write it as is. Here I have a trinomial. I know a trinomial eventually factors into 2 brackets. I know that the first term in each bracket will multiply to give me x squared. So I'm going to try x and x. And I know that the second term in each bracket will multiply to give me 12. Now, when you think of the number 12, there's a lot of numbers that multiply to give you 12. So you can write it out on the side. 1, 12, 2, 6, 3, 4. Whenever you're factoring, you always want to try the closest numbers first and then move to the other numbers if needed. So 3 to 4 are the closest numbers. We'll put 3 and 4. Once you do this, you do the double smiley. So 3 times x becomes 3x, and 4 times x becomes 4x. Remember, you have to choose what sign is associated with the 3x and the 4x so that both of these terms add to give you that middle term. So I have a 3 and a 4. I need to get to -7, so I'm going to put a negative in front of the 3 and the 4. Because this negative is associated with the 3, there'll be a negative in front of the 3. Because this negative is associated with the 4, there'll be a negative in front of the 4. Now, this is how you write this in factored form. The whole point of this worksheet, of this page, was to determine, well, what's the significance of factored form? So take a look at our factors. So I'm going to write them down here again. Factors. We have x minus 3 and x minus 4. Now let's compare these to our x-intercepts of this particular parabola. So we have our x-intercepts. The first x-intercept is here at 3, 0. And the second x-intercept is here at 4, 0. What you should notice is that they're opposites. Here in the factor it says -3, but the x-intercept is +3. Here the factor is -4, the x-intercept is +4. Now, I want you to pause this video, do the remaining 3 questions, factor them out, and then compare them to their x-intercepts. I want you to do this. Eventually, I'm just going to quickly take up the answers so that we see the pattern. Okay, so if we want to factor this, again, I'm not going to show you the factoring steps. That should be reviewed, but fx is equal to x5, x3. This would be plus, and this would be minus. If I compare this to the x-intercepts, we have an x-intercept here at 3, 0, and another x-intercept here at -5, 0. Again, we see the opposite. The factor had a +5, the x-intercept is -5. The factor had a -3, the x-intercept is a +3. Moving on to this question, again, we factor it. And we compare the x-intercepts. So if we take a look at the x-intercepts, again, the x-intercepts occur at 2, 0, as well as here, -10, 0. And we see it's the opposite. +10 in the factor, -10 x-intercept, -2 in the factor, +2 x-intercept. You should be seeing a pattern now. And we have x, x6, 2, plus, and minus. Again, when we look at the x-intercepts, we see there's one at 6, 0, and another one at -2, 0. When we compare it, we see the same pattern. They're the opposites, -6, +6, and +2, -2. So what's so special about factored form? Well, we can tell where the x-intercepts or zeros are. This is important. These are synonyms. So they mean the exact same thing. If I ask you for an x-intercept or if I ask you for a 0, essentially you're finding the values of x where the function crosses the x-axis. So we can easily tell the spots on the x-axis where a parabola will slice through the x-axis. These are very important points which we'll learn more about later. So up until this point, we really used vertex form in order to graph parabolas, and they work fine for graphing parabolas. When we have factored form, what we really get out of it are the x-intercepts or the zeros. And when we do application questions later on, you'll see why these are important. So for this exercise, it says state the zeros of each quadratic function by first rewriting the equation in factored form. So you should recognize that when they give you a quadratic equation like this, it's standard form. So let's make it into factored form first. And I want to show you the process by which you find the zeros. So here, we're going to write y, and we need to factor this expression on the right. So because it's a trinomial, again, I'm going to have my two brackets. Again, you should be able to do this, but I'll show you one more time how to factor. So the first term in each bracket should multiply to give you x squared, which is just x and x. The second term in each bracket should multiply to give you 16. And again, when you have a number that has multiple factors, so in this case, 1 and 16 makes 16, 2 and 8 makes 16, 4 and 4 makes 16. You do start with the closest one first, but to save time, I'm going to tell you that this closest one doesn't work. So we're going to move on to the next one, 2 and 8. We look at the inside smiley, that's 2x. The outside smiley, that's 8x. And we want to essentially get to -6x. So we need to put pluses and minuses here to get to -6x. So the easiest way to do that is +2 minus 8. So because the plus is attached to the 2, it will appear here. And because the negative is attached to the 8, it will appear here. So this is the equation in factored form. Now to find the zeros, so remember zeros are just another fancy way of saying x-intercepts, we can do what we've been taught to do all along. To find the x-intercept, we need to let y equal 0. So we have this equation, and we're going to say 0 is equal to x plus 2 and x minus 8. In this case, we need to set each factor to 0 and solve. So the way you solve these equations is you split it up. You say 0 is equal to x plus 2, and 0 is equal to x minus 8, and then you isolate for the x here. So x, I bring the 2 over, 0 minus 2 is just -2, and here x, I bring the -8 over to make it positive, it equals 8. So based on these values, I know that my x-intercepts occur at -2, 0, as well as 8, 0. That's the formal process of finding the x-intercepts. I want you to get used to that because, yes, we've found that pattern that the opposite of the factors give you the x-intercepts, but this isn't always the case. So we do need to make sure that we're following these steps. So again, what you did here was, let's write it out. You first first factor equation. Then the second thing you did was let y equal 0. The third thing you do is set each bracket to 0. So that's what we did up here. This factor was set to 0 and this factor was set to 0. So maybe I'll clarify, set each bracket, that makes sense, set each bracket or factor to 0. And then solve for the x values. The last thing you want to remember, these just give you the x values. I've always said x-intercepts should be points, so you need to write them out as points. When you have x is -2, remember you made y 0, so you get -2, 0. And when you get x is 8, again, y was 0, so 8, 0. I'm going to show you one more example. The last two you should try on your own. So looking here, we have y is equal to this expression. Before we begin, if ever you see a negative value attached to the x squared, you want to factor out that negative value. So factor out the negative value, leaving you with x squared plus x minus 12. Then continue to factor. So again, I'm not going to show you the entire factoring process, but I expect you to go through this when you're doing this question. And that's the factored form. So again, we want to find the x-intercepts, so we'll follow these steps. We factor the equation, let y equal 0. So 0 is equal to negative x plus 4, x minus 3. Set each bracket to 0. So here we have x plus 4 is equal to 0, and x minus 3 is equal to 0, and then isolate for the x value. So x is equal to -4, and x is equal to 3. Don't forget, you're not done. You've simply found the x values. You need to write the x-intercepts. So x-intercept is -4, 0, and 3, 0. Now I want you to pause this video and do these last two questions. Check your work, do the last two questions, and then once you're done, play the video again, and I will have the answers here so that you can check your work. So pause the video now. So I have the answers to the last two questions here. This question worked exactly like the others. Something to remember here, if you end up with the same factor, you can write it as x minus 3 squared. In fact, you should write it as x minus 3 squared. And so when you solve it, you'll notice that there's really only one bracket to set to 0, x minus 3, so x is equal to 3. So it is possible for parabolas to have two x-intercepts. It's possible for them to have one x-intercept, and in the future, we're also going to look at how it might be possible for it to have no x-intercepts.